And I'm going to be starting these problems. Okay, so the first problem is a example of an inequality. And we're asked, actually A and B are both inequalities, and we want to solve them and put the solution in interval notation. Okay, so remember when we solve an inequality, we're doing it just like we do an equation. We're going to remove the parentheses, get all the variables to one side. We're always going to try and bring in an equality. The variable to the left and the numbers to the right. And then we're going to look at the solution and we'll actually put it on a number line as well. So of course, the first thing we're going to do is remove the parentheses. So -5 times 5x is -25x. And -5 times 14 is -70. So we have -25x minus 70 is less than -30x minus 40. And we're going to add the 30. Remember, we want to get the x's to the left. So I'm going to add 30x to both sides. -25x plus 30x is going to give us positive 5x minus 70. This is gone, is less than -40. Notice we keep the direction of the inequality the same no matter what. Then, of course, we're going to add 70 to both sides. Okay, so I'm going to go over here and finish this up because we don't get it running into space problems. So I'm going to be getting 5x less than, because this is gone now, -40 plus 70 is 30. Divide everything by 5. So my solution becomes x less than 6. Notice I did not change the direction of the inequality because I divided by a positive number. Only if you divide or multiply by a negative number do you switch the direction of the inequality. On your number line, it would look like this. Here's your 0. Here's 1, 2, 3, 4, 5, 6. Here's our 6. Since it says x is less than 6, it's going to be an open circle at 6 because the 6 is not included and the arrow is going to the left. I didn't ask you to graph it on the number line, but actually it makes it easier to put it in interval notation because you see that all the way to the left is your -infinity. Remember, with infinity signs, you always use a regular parentheses. You're going until 6, but you use a parentheses there because the 6 is not included. So that should have been your answer. Okay. Does anybody have any question about that? All right, so let's try the next one. Now, the next one is what we called a double inequality or a compound inequality, where we have 20 less than 5x plus 5 less than or equal to 40. Now, remember what we said about these double inequalities, these compound inequalities. They're really a shortened way of writing two things. One inequality they're writing is that the 20 is less than the 5x plus 5. And the other, in other words, just this. The other inequality they're writing is 5x plus 5 is less than or equal to 40. So it's saying two things at the same time. Both this and that is happening. It's a compound and situation. And the easiest way to do it is to work it as double inequality, just remembering that what you want to do is get the plain x in the middle. You want X in the middle, you focus on what's happening in the middle here, and whatever you're going to do to isolate your X in the middle, that's what you're going to do at either end. So the first thing, obviously, we're going to want to do is get rid of this 5. So if I subtract 5 in the middle, I've got to subtract 5 at either end. So 20 minus 5 will give me 15, is less than 5x. This 5 is gone, is less than or equal to 40 minus 35 is 35. Again, I go back to the middle. I want a plain X here, so I'm going to have to divide by 5. So therefore, I'm going to have to divide by 5 on either end. Remember, I'm really doing 2 problems at once. So 15 divided by 5 is 3. We're dividing by a positive number, so our direction of our inequality remains the same. 5x divided by 5 is x. And 35 divided by 5 is 7. So here is your solution as an inequality. Don't write x equals 3 and x equals 7. This is not an x equal sign, or don't just write 3 and 7. When you're dealing with inequalities, you must write your solution as an inequality or an interval notation. Let's go look at this on the number line. Here's 0. Here's my 3. Here's my 7. Okay. Now, what this is really telling me is that the x is between the 3 and the 7. It's greater than the 3, but also less than or equal to the 7. Now, at the 3, we're going to have an open circle. But at the 7, we're going to have a filled-in circle because it's a less than or equal to. And we fill in everything in between. It's not, doesn't go till infinity. It just goes between 3 and 7. In interval notation, it's going to be in parentheses by the 3 because that's an open circle. And here's my 7 with a brackets because the 7 is included. There's a closed circle by 7. Notice you could have done it. Notice how easy it is, or how it really looks just like this. It's leaving out the x. It's just putting in the 3 and the 7. Again, be very careful with those notations because one means include the number. When it's just a parentheses, you don't include the number. It's an open circle. When you have the brackets, the square parentheses, it includes the number, and that means it's a filled-in circle on your number line. Again, is there any question about these? All right, so let's look at this last problem. This last problem is a review of what we had done as the last topic last Wednesday, our last class. And this is what's called an absolute value equation. These 2 lines stand for the absolute value. This is read the absolute value of the 2x minus 4 minus the 7 is equal to 3. And the way we solve, if you recall, the way we solve an absolute value equation is first we isolate our absolute value. If there's anything on the side where we have the absolute value, if there's anything outside that absolute value, we've got to get rid of it. And in this case, we do. We have a 7. So I'm going to add 7 to both sides, which gives me that the absolute value of 2x minus 4 equals 10. Notice we now have our absolute value all by itself. And now I pause for a second and I look at this number that's on the other side of the absolute value. Remember, the absolute value always means the positive value of a number. You can never have the absolute value being negative. So this number is negative, you're finished. You can't do that problem. It has no solution. But in this case, it is positive. If it's positive, we go further. And the way we go further is by breaking this up into two separate equations. One equation is just the 2x minus 4 equaling the 10. The other equation is the same 2x minus 4 equaling negative 10. That's because since the absolute value, the 2x minus 4 is inside the absolute value sign, it must mean it could have originally been a positive 10 or a negative 10, because both of those numbers have absolute values equal to positive 10. And now we just solve these two equations. I'm going to add 4 to both sides. This will give me 2x equals 14. So this one turns out to be x equal to 7. And this one, when I add 4 to both sides, I get 2x equals negative 6. So in this case, we get x equals to negative 3. So our two solutions, and they're very often put in this braces thing. When you see this, it just means it's a list of the solutions are negative 3 and 7. Here's our solution for this. Here's our solution for this. They happen to have the same answers, just a matter. And there's the solution for the first one. Does anybody have any questions before we go on to some new work? Okay. So the first thing I'm going to do is I'm going to erase what's on the board and put some new type of problems on. Okay, so what I'm going to do first now, and I hope everybody has a calculator. Remember, I asked you to make sure you get a 2-line scientific calculator. I'm going back to talking about solving linear equations, the very first topic we reviewed. But what I'm going to do is I'm going to first talk about what happens if we have decimals inside our equation. And then I'm going to talk about what happens when we have fractions in our equations. Actually, a little bit later on in the term, we're going to be doing more on fractions. But at this point, you should be able to solve equations where the numbers are all whole numbers, positive or negative. The numbers might have decimals and they might have some fractions. So that's what we're going to be doing today. How do we deal with fractions? And how do we deal with decimals when they're in an equation. And of course, whatever we're talking about that applies to equations would apply also to inequalities, and it would also apply to absolute value equations. So let's see if we could do a problem like this. Okay, so what this is saying is that I have 0.08x plus 0.09 times 9,000 minus x equals 750. Now, you might have learned a method in which you can multiply everything by, since there are two decimal places, by 100. But I'm going to show you, if you have a calculator, you could just work it with your calculator. So if you have a calculator handy, take it out right now so we can work this problem with the calculator. All right. So again, it's an equation. The first thing we want to do is get rid of the parentheses. So I'm going to have 0.08x plus, okay, now have to multiply everything in this parentheses by 0.09. So I take out my calculator and I do 0.09 times 9,000. And that gives me 810. Of course, you could have done this without a calculator, but you're more likely to be accurate, and it's certainly quicker if you're using a calculator. Then you have to multiply the 0.09 times the negative x. Well, obviously, that's going to be 0.09x, and that's going to equal our 750. So we removed our parentheses. Okay, next step, combine the like terms. Now, the like terms we have in terms of the x is the 0.08x minus the 0.09x. Now, again, you could do this in your head, or you can use your calculator. Remember, when you're combining variables, you just combine the numbers that are in front. So I'm going to put 0.08 minus 0.09, and it's going to give me negative 0.01x. Notice I didn't put in the x's because it's a calculator. It doesn't, so it's just a regular scientific calculator, but I can put in the coefficients. That takes care of combining the like terms. This is 810 equals 750. So of course, the next thing is I have all the x's over here. I want to get rid of this 810. I'm going to subtract 810. Which will leave me negative 0.01x. Notice the 0 in front of the decimal point doesn't have to be there. It's just to indicate that this is where the decimal point is. So if you just wrote 0.01 without that first 0, that's fine also. And this equals 750 minus 810. Of course, again, I could do this without my calculator, But since have my calculator out anyhow, you'll see that I use the calculator a lot. I happen to like using the calculator. I find it's quick and it's correct. Okay, so now I'm going to divide by the coefficient of the x, which is negative 0.01. And I'm up to my last step. Here's my x. My x is going to be the negative 60. And since I still have this negative 60 on my screen, I don't have to retype it. I could just put in divide and put in negative 0.01. And it gives me as my final answer 6,000. So it works just like a regular equation. You just have to be careful with your decimals. Again, if you're using a calculator, it will make life much simpler for you if you do it. If you do the work with a calculator. I'm going to give you one to try now on your own. I'm going to put it over here. And then while you're working it, I will take attendance. Okay, here's the problem. Negative 0.05x minus 0.08 equals, I'm going to put it on the next line because I'm sort of running out of space. 0.03 minus 0.04 times 2x minus 1. Okay. Now I'm going to leave this on the board for a few minutes. I'll recopy that over here when we're doing it. And I'm now going to take, while you're doing this problem, I'm going to be calling attendance. Okay. Olivia.
Here.
Good, thank you. Isis.
Here.
Good morning. Alvaro. Alvaro Blake. Lewis.
Here.
Hi, good morning.
Morning.
Emma.
I'm here. Good morning.
Good morning. Demetrius. Demetrius. Desmond. Shania. Shania.
I'm here. I'm sorry.
That's good. Thank you. I'm glad you're here. Caden Ricardo. Kayla Harris. Sanjita. Okay, thank you, Kayla. I see you're here. Sanjita? And if I'm saying your name wrong, tell me. I think I saw you before.
Yes.
Okay, thanks. Oriana, I know you're here because I spoke to you. Tahira,
Here.
hi, good morning. Michaela? Michaela? Kiana? Kiana, hi, good morning.
Good morning.
Carly? Carly? Hi, good morning. Jenna?
Yes, I'm here with Jenna.
I'm glad you're here. Tatiana?
Here.
Hi, good morning. Naya Sims, I saw you came on, Naya. Kazandu? Kazandu Small? Trainer Small? Jean Thomas? Hi, good morning. Don't forget, when you're finished, see if you can put your answer on the chat. I'll give you a couple of more minutes. All right, let's see if we could go ahead and do this. Now, if you notice, when I rewrote the problem, I didn't put those zeros in front of the decimal points. They're just there to make the decimal point obvious. They have no function. You don't have to put it into your calculators. I'm going to actually now work the problem without it. If you notice, I tried to make my decimal points very large so that they were obvious. Okay, but again, we're going to do what we did before. We're going to first try and remove any parentheses. And the only place we have parentheses is at the end. So I'm just rewriting this. Negative 0.05x minus 0.08 equals 0.03 minus, okay, now we're multiplying the parentheses, what's in the parentheses. And again, you could do this in your head or on a piece of paper, but I'm using my calculator. I want to multiply the 0.04 times the 2. Remember, I can't put in the x, but I can certainly put in the coefficient. And of course, that gives me 0.08. Now we put in our x. And then I have the 0.04 times -1, which is of course negative 0.04. Okay, now this we're going to leave alone. I'm just gonna rewrite it. 0.05x. It just takes a lot of time to write because there are all those zeros. And now I'm on my right side, and what I have to combine is the 0.03 and the negative 0.04, because those are the constants. They don't have any variables. So I do 0.03 minus 0.04. I know you could do this without the calculator, but I just want to show you that if you use your calculator, you're going, okay, this one doesn't have an X. You're less likely to make any mistakes. And then, of course, I just bring down the 0.08x. Okay, so I want to get the x's to the side. So I'm going to add 0.08 x to both sides. So on my calculator, I'm going to be doing negative 0.05 plus 0.08, which will give me 0.03. Of course, this is got an x next to it. Minus 0.08 equals negative 0.01. Remember, there's a very big difference between the negative sign and the subtraction sign. When we use it on the board or when we write something, and this looks exactly like this. This means subtract 0.08. This means negative 0.01. Effectively, they mean the same. But when you're using your calculator, you have to be careful when you're using, if you want to put in a negative number, that you push your negative button, not your subtraction button. Okay. So my next step is I want to add 0.08 to those sides to get rid of the, so that I only have the x's over here. So here I'll have 0.03x. And now I'm going to be doing negative 0.01 plus 0.08, which gives me 0.07. Somehow I think I made a mistake here someplace. Oh, nobody corrected me. I see I made a mistake. I'm sorry. Let's go back. I've got to go back because I see I've made a mistake. I'm going back. Easy for me to correct my mistakes. I just have to erase it with my board. I had over here, I had a negative 0.04 times a -1. That should have been, nobody caught me on that one. A negative times a negative is a positive. Sorry, I made a mistake. Okay, let's go back. Now we can continue from here. Just rewriting this, negative 0.05x minus 0.08. And now I have a 0.03 plus 0.04. These are both positive, which gives me 0.07. Minus 0.08x. Okay. Now I'm going to add this 0.08x to both sides. You might have asked me how I realized I made a mistake. I happen to have known what the answer to the problem was, and I saw I wasn't getting that answer. I know you don't always have that option. Our tests, the midterm and the final, which are the major tests of this term, are multiple choice. Sometimes you come up with, and they don't try to trick you in terms of saying none of these choices. That's always, so if you don't come up with one of the answers that's on that sheet, then you know you've probably done something wrong and you've got to re-examine. So that's really what I saw over here. I knew that the answer was not coming out right, so because I knew what type of answer to look for. Okay, going back to this, the negative 0.05 and the plus 0.08 we had from before is 0.03x minus the 0.08 equals the 0.07. This, of course, is gone. So my next step is to add the 0.08 to both sides. This will leave me the 0.03x on the left. On the right, I have to have 0.07 plus 0.08, which is giving me 0.15. You have to be careful with the placement of the decimal point. Really, that's the only thing that's making this difficult, is that decimal point. The rest of it is easy, it's just regular numbers. Of course, now I'm going to divide by 0.03 on both sides. Which gives me, again, I'm doing this on my calculator, 5 is my final answer. Anybody got 5 as an answer? If I had had this problem, there had been no decimal points in the problem, I'm sure everybody would have gotten correct. Get used to practicing using your calculator. Later on in the term, not only the calculator will not be an option. There's certain things that we can only do when we have a calculator. Get your calculator now. Get it. Remember what I told you, a 2-line scientific calculator. It will make your life much simpler if you get used to using your calculator early. If you're not allowed on the final and on the midterm to use a graphing calculator. If you have a TI 85 or 84 or 83, that is really not allowed on your tests. If it's all you have right now, you can use it, but get a simple 2-line scientific calculator and get it now, because now they're on sale. I see them. One of my grandchildren needed a scientific calculator, so I was looking online with them for it, and you can get them for 12, for 15, certainly under $20. As I said, if you want to buy the book, that's your option. It certainly is a good idea to have the book as a reference, but I'm not checking if you have the book, but the calculator is not an option. You must have a calculator. Does anybody have any questions about this before I go on? Okay, so then let's talk about what happens if we have a fraction in an equation. And we're going to do ones that are simple fractions. Later on, as I said, in the term, there's a whole chapter on dealing with fractional expressions, algebraic expressions that have fractions. And we're going to spend time doing it. But at this point, you should be able to solve an equation if it has some fractions in it. So let's see how we could go about doing that. So I'm going to, any questions about this, or can I erase this? Suppose I had an equation that looks like this.
So, first things first on the steps, without your hand.
Suppose I gave you this equation. 9/5 y plus 6 equals 3/8. Okay, this is a regular equation, and we're looking to solve this for y. It's not an absolute value equation. It's not an inequality. It's just a regular linear equation. The problem being that there are fractions in it. And we could use our calculator to work out the fractions, but I think the easier way to deal with equations or inequalities with fractions is to somehow, right up front, try to get rid of the equations. Now, how do we do that? So the first thing we want to do is make sure that everything in the equation is written as if it's a fraction. which means in this case, we happen to have the 6, which isn't a fraction. So any whole number you can make into a fraction by putting it over 1. Make sure everything is in fractional form. This is also over 1. So rewriting this, I have 9 over 5 times y over 1 plus 6 over 1 equals 3 over 8. Now, if you remember when you're multiplying, this is the first thing we see here is we want to, let's combine things and write them as single terms. And here I have 2 things. I have a 9 over 5 times a y over 1. Now remember, when you're multiplying fractions, what you do is you multiply the numerators and you multiply the denominators. So this will become 9y over 5 times 1, which is 5. And now we have everything written as a bunch of individual fractions. And what we do is we look for what's called the common denominator of all these fractions. What do we mean by the common denominator? I'm going to show you when it comes to when there's much more complicated fractions, I will show you a different method. But when you have relatively simple numbers, and 5, 1, and 8 are relatively simple numbers, what you're looking for in a common denominator is a number that every single one of these denominators will every single one of the denominators will divide evenly into. Okay. One way of doing that is to look at the largest number. The largest denominator here is 8. Now, let's see. Does 5 divide evenly into 8? Obviously not. And I could just keep going. 8 times 2, 8 times 3, 8 times 4, 8 times 5, until I find a number that they all go into. Equally, I could have just multiplied the 5 times the 8. Notice 40 is a common denominator. It might not be the smallest, it might not be the least common denominator, but multiplying the numbers together, if they're not too large, is a way of finding a common denominator. In this case, my common denominator, my LCD, my least common denominator, happens to be 40. What do you do then? You take this LCD, which is 40, and put it over 1. So you take your LCD and put it over 1, and multiply the whole equation by that number. Which means we're going to have to distribute this common denominator. So what we're going to get, I'm going over here, is 40 over 1 times 9y over 5 plus 40 over 1 times 6 over 1 equals 40 over 1 times 3 over 8. Now, why have I done this? Well, let's see what happens at our next step. Let's go to this first set of fractions. We're multiplying 2 fractions, 40 over 1 times 9y over 5. You may recall when you're multiplying fractions that what you do is you multiply, you first try to cancel out any numerator with any denominator. And in this case, the 40 and the 5 can be what we call cross cancel. Both, if I divide the 40 by 5, I will get 8. And if I divide the 5 by 5, I get 1. So that this first fraction becomes 8 over 1 times 9y over 1, which means when I multiply it, I'm getting 72y over 1. Remember, when you're multiplying, first try to cross cancel any numerator with any denominator. It can't be two numerators, it can't be two denominators. It has to be a numerator with a denominator. And then you just, after you've done the cross canceling, multiply the numerators together, the two tops together, 8 times 9y is 72. Multiply the two denominators together, 1 times 1 is 1. Let's go to our next. Over here, there's nothing to cancel out, so I just multiply the numerators. 40 times 6 is 240 over 1. And finally, on the other side of the equation, I have 40 over 1 times 3 over 8. And again, I can cross cancel it. I can divide the numerator and denominator by 8. So this will become a 5, and this will become a 1. And now I do the same thing. Multiplying 5 times 3 gives me 15 over 1. And I'll tell you a secret. Since we multiplied by the LCD, by the least common denominator, every single one of the numerators and denominators, they will cancel out, so that all we're left with in the denominator are ones. Now remember, everything over 1 can be written as just a regular number. So this becomes the equation 72y plus 240 equals 15. In other words, by multiplying everything, it looks like it takes a lot of time, but once you get used to it, it's really quite quick. And once you've done that first step of multiplying everything through by the common denominator, you're left with an equation or an inequality or whatever you're left with, whether what you started out with, without fractions. So it's just easy to finish this up. Subtract 240 from both sides. So I'm going to get 72y equals, I'm going to use my calculator. 15 minus 240. Anything that I can't do in my head, doing on my calculator. And then I'm going to divide by 72. And I get as my answer negative 3.125. There's nothing that says that the answer has to be left in decimal form. You could have also just reduced this fraction. Alternatively, if you notice, the top and the bottom can both be divided by, I think, 9. So the other alternative is to divide the top and the bottom by 9, and you'll get negative 25 over 8. So here's the answer in decimal form. Here's the answer in fraction form. Either in this case would have been completely correct. All right. Now, this was a pretty hard one because the numbers were not so simple. I'm going to give you one to try. Okay, let's say I gave you this example. I'll leave the bottom part on if you still feel you want to look at that. And I'll give you an example to try. I'm going to give you one that's an inequality rather than um, let's see if you could solve this inequality that happens to have a fraction in it. Give you a few minutes to try that. Okay, let's see if we could work on this together. No problem, Wish. Okay. We want to solve this inequality, and remember, the way we solve inequalities is the same way we solve equations. So let's remember what I said about equations that have fractions. Put everything that's not a fraction over 1. So it's very hard to deal with something that's a combination of fraction and whole numbers. So just make everything, and you can't make the fractions into whole numbers necessarily, but you can make the whole numbers into fractions. Okay, so that will leave us as -7 over 1. Minus, remember what we said when we have two fractions right next to each other, which means they're being multiplied. We just multiply the numerators together, so we get the 3x. And we multiply the denominators together. The 4 times 1 is 4. That's less than or equal to 2 over 1. Okay, so now we have everything as individual fractions. Again, anytime you have a fraction next to a whole number, it really means that you're multiplying the numerator together and the denominator together, so you get a single fraction. Now, if you recall what I said last time, the first that after I have everything as a as everything as a fraction, I'm gonna look for my common denominator. Now, the common denominator here is gonna be very easy because the only denominators we have are 1 and 4. And the numbers, remember, we're looking for a number that both of them will divide evenly into. And obviously, 1 divides evenly into any number. So the only thing that we need to worry about is this 4, our common denominator, our LCD, in this case, is 4. Or alternatively, I could have just multiplied the denominators together. 1 times 4 times 1 gives us 4. So I'm going to multiply this whole equation by 4/1. And since I'm multiplying by a positive number, it will not affect the inequality. So I'll have, remember, I'm going to distribute this number, multiplying everything. As long as I do the same thing to both sides of the equation, I'm not changing my equation. So I'm going to have 4/1 times -7/1 minus 4/1 times 3x over 4 less than or equal. Remember, we keep it the same because this is a positive number we're multiplying by. 4/1 times 2/1. So let's see what we have. Over here, our two denominators are 1, so there's nothing to cancel out. We're just getting -28/1. Over here, remember, we try to cross cancel, and I have a 4 in the numerator and a 4 in the denominator. I can divide out the 4 in the numerator and the 4 in the denominator, which will leave me then 1's in place of that, so I'll have -1 times 3x, which is -3x, over 1 times 1, which is 1. And that's less than or equal to, again, here, nothing to cancel out because the denominators are already equal to 1. It's 4/2 times 4/1 times 2/1 gives us 8/1. And notice, once we have all our denominators being 1, this is the hard part. We've done the hard part. We now have an inequality or an equation that has no fractions. So I can really write this as -28 minus 3x is less than or equal to 8, which is what we've been dealing with all along, a regular inequality. Now we solve this the way we've done all along. We want to leave the x's on the left side, get all the numbers to the right. So I'm going to add 28 to both sides. This will leave me -3x less than or equal to 28 plus 8 is 36. And then I have to divide everything by the -3. Remember, since I'm dividing by a negative number, and when you have an inequality, anytime you're dividing by a negative number or multiplying by a negative number, the direction of the inequality switches. So we're now getting x, because -3x divided by -3 is x, greater than or equal to 36 divided by -3, which is -12. And our solution for this inequality is x is greater than or equal to -12. If we're putting it on a number line, let's just remind ourselves, let's say here's the -12, it's someplace to the left. It would be a filled-in circle because it's greater than or equal to, and the arrow is pointing to the right. Here's my linear solution, my graphic solution. Here's my inequality solution, and here's my solution written in interval notation. My first point is the -12. And we have to use a bracket with a -12 because it's filled in. And it's going all the way to infinity. And remember, with infinity, we always use a parentheses. So this is no different than doing a regular inequality, except getting rid of that fraction. Again, it looks complicated now because I'm doing it very slowly, but if the fractions are not difficult, and I will not give you very difficult fractions to do, you can do it, just multiply everything by the common denominator, and that gets rid of the fractions. You don't even have to write in this extra step here. You could have gone right away. As soon as you know everything's going to be 1 on the bottom, you just can write it without the ones. The only time you need those ones as denominators is when there are other types of fractions and you want to make sure you're looking at everything as a fraction, because you don't want to mistake what is a numerator, what's on top, with what's a denominator, which is on the bottom. And if you just have a whole number, sometimes you make a mistake. So put it over 1 and you'll always know what's on top and what's on bottom. Okay, I just want to do one more type of example. And that will bring us up to starting chapter 2 on Friday. Chapter 2 is a chapter on graphing linear equations, how to graph lines. And if you really want to be able to do this accurately, you really are going to want to try and do it on graph paper. Now, I don't have a graph board, so I'm going to have to like hand do it. All I can tell you is get yourself a pack of 10 sheets of graph paper, or get a graph notebook or whatever. You can use a graph paper for anything, but if you do the graphing on graph paper, it becomes much clearer and easier to understand what we're going to be doing. So that is your homework for Friday. Again, keep looking at the Delta math, because there are going to be examples on Delta math, and I'm thinking of maybe we should be having a quiz on Delta math in the near future, and I'll let you know on Friday what that schedule is going to be. But make sure, even if you miss the deadline on the homework, it does not disappear. I set it up so that there's a late date on the homework. So if you do it later, fine. It doesn't matter. When it comes from me figuring out that portion of your final mark that comes from homework, what I'm looking for is not what mark you got on the homework, but did you do the homework? So even if you got 60% on the homework, it's not going to go down as it's just going to be as a check mark. Your homework was done. The final, at least 10 points of your final grade comes just from the Delta math homework. So make sure you get it done. Otherwise, you're going to not have. It's an easy 10 points. I mean, I shouldn't say easy because it does mean you're sitting down, but it is not dependent on what grade you get. It's dependent on you doing the homework. Okay, so what I want to do is talk about word problems. Verbal problems are really what math is all about. What we really want to do, the most important thing that we should be doing now, is somehow taking things that we describe in words and translating them into algebraic equations or inequalities or some sort of algebraic expressions and solve what so that we can solve the things mathematically. It's the most important part of mathematics, because if you can't apply what you're learned to real life, there's no real reason for this. So during the course of the term, we'll be talking about various what we call applications of mathematics. Now, sometimes the term used for real life applications is mathematical models. We're going to try and use our math to solve real life types of problems. And I'm not going to do them all in one session. I'm going to disperse them through different parts of the term, depending on what kind of equations that we're going to be using. So today I want to talk about something that's called solving perimeter problems. And specifically the perimeter of a rectangle. Now, the reason we talk about rectangles so much is because if you look around your world, most of the shapes that we use in construction, in everyday life, is either a rectangle or a square, the screen on your computer. My whiteboard. Your rooms, most rooms are rectangular. They're either square or rectangular. You're not saying that sometimes you don't get something with a curve, but most rooms, the doors, the windows, the beds, life is made up of rectangles. So we often have a lot of examples that have to do with rectangles. And the two things that we really deal with in rectangles are the area of the rectangle and the perimeter of the rectangle. So today we're going to talk about perimeter. When we talk about the perimeter of a rectangle, here's a rectangle. It means how much is it all around the rectangle. If you wanted to make a fence around a backyard that is a rectangle, you would be looking for the perimeter of the rectangle. How do we find the perimeter? Well, in a rectangle, two sides are called the lengths. Notice the opposite sides of the rectangle are equal. That's what makes it a rectangle. So this one is a length. And this is also a length. And two sides are called the width. Now you could have called this the width and this the length, it's fine. The formula for finding the perimeter of the rectangle can be done two ways. We could just add all the sides, L plus W plus L plus W. Just add up all the sides, that's the simple way. Or if you want to combine the like terms, you're getting 2L plus 2W. That's how you find the perimeter of a rectangle. In other words, if the length in this case would be 20 and the width was 11, your perimeter would be 20 plus 11 plus 20 plus 11, which is 31 and 32, which gives you 62. Or you could have done 2 times 20 plus 2 times 11, which would have also given you the 62. In other words, your perimeter is all the sides added up. So let's see what kind of an example could involve a perimeter. Suppose I told you that a construction company builds a swimming pool with a perimeter of 58 meters. Okay, so we have a rectangular swimming pool that we're constructing. And the total perimeter of this swimming pool is 58 meters. It turns out that the length is 11 meters more than the width. What are the dimensions of the swimming pool? Now, the dimensions means it's a generic term for length and width. So when they're asking for the dimensions, they're asking what is the length and what is the width. So here's our situation. We have this rectangular swimming pool. We know its perimeter is 58. You don't have to put in the M. We know it's meters. Let's see if we could express the length and the width in terms of a variable. Okay, so it's telling us the length is 11. Put this more, I'm sorry, more than the width. Okay, so let's call the width X, which means this is going to be X. This one is also going to be X. Now, to say the length is 11 more means you're adding 11. It's X plus 11, which means this is also X plus 11. So I've expressed all 4 sides of this rectangle in terms of X. Our X is our width, and we're calling the length X plus 11. Remember, more than means plus 11. If it would have said the length is 11 less, here's where you have to be careful. With more, when you're adding, it doesn't matter if you put the add to the front or at the back. But if this would have said the length is 11 less than the width, you would have had to say it's X minus 11. Even though when we say it, we're putting the 11 first. To say something is less means the 11 less means the 11 is being subtracted. Okay, in this case, we had more. Let's see how we figure this out by writing an equation. Well, we know the perimeter in terms of X would be all 4 sides added together. So if I add these all together, I'm going to get X. I have 4 X's plus 22. That's X plus 11 plus X plus X11. Add it all up, it gives you 4X plus 22, which we know is equal to 58. So we're going to subtract 22 from both sides. Regular equation now. We have made a mathematical model. This 4X plus 22 equals 58 is a mathematical model of this real life situation. It's an equation that we can use to solve what we're looking for. Now, 58 minus 22 2 is 36. And if I divide by 4, I get x equals 9, which means my width is 9 and my length is 9 plus 11, x plus 11, which is 20. And my dimensions are, I can write it either as the width is 9 meters, the length is 20 meters. I could write it that way. Or I could write the dimensions are 9 by, sometimes you use an x, 20. Is another way of writing it. But when they're asked for the dimensions, you're asked for both the length and the width. Okay, I think we're going to stop right here. Remember, as I said, I am not going to be putting any new homework on for Friday on Delta Math, but there will be homework for Monday. So at this point, you don't have to look, but certainly by over the weekend, I will be probably posting it tomorrow, additional homework, which includes some of the things that we've learned today. Friday, we are going to be starting again how to do what's called coordinate geometry graphing on an X and a Y axis. We're going to, I'm sure some of you have done that before, but that's what we're going to be doing. Any questions? All right, so then I'm going to close the recording.